Hey all, welcome to my YouTube channel Thursday Content. My name is Padmaja. I'm back with another video this time, and this would be on CNN. So basically image classification with CNN. So the data set what we would be using for this exercise is this Intel image classification, and this has basically 6 classes of data such as buildings, forest, glacier, mountain, sea and street, and basically it has train, test and pred data sets. Train has roughly around 14,000 images, test has roughly around 3,000 images. So these are the images which we will be using for our image classification. So let's get started. So basically we will be having 3 different files here. So this image classification with CNN will be our base file, base model file, where we will be training the CNN model. And this is predict image class.py. This is where we will be writing the Streamlit app for the UI. So we are not going to use Flask here, we will be using Streamlit. And the third one, predict image class.ipython notebook, we will be using to run the Streamlit app. So if it is in local, we usually take help of shell, but since it's in collab, we have to have another file. We can of course merge here, but it would get little clustered, hence I have done a separate file altogether. So these are the files which we will be using. So I've already created all of them, so we can get started directly. So basically we got our drive mounted here, so you can see we have the Google Drive here. So this is the first step. So let's import all the required libraries here. So first is OS, and then it would be pandas, and then it would be NumPy, and we'll be using matplotlib for visualization, and then we have CV2. We will also import image IO, and then it is pathlib, and the last one is matplotlib inline. So these are the libraries which we will be using for our this particular notebook. So we will also check if our notebook is connected to the GPU. Of course we can go here and check. It says GPU, else we can just run one liner code, TensorFlow STF and tf.test.gpu under device name. This should give 0. It takes some time sometimes. Yeah, we got the output. So we are connected to the GPU. So this is essential for all our images. And then next we will be giving the train and test data path, the folder paths we will be giving. So the first step we will be importing is our image data generator. So tensorflow.keras.preprocessing.image, we import image data generator. Yes, and then image data generator, we rescale all the images and we save it and rescaled. So all the pixel values will lie between 1 to 255. So basically what image data generator does is it gives all the images as image tensor in batches. The number of the batches we will define here basically. So next step is we will be giving the path for our train data set, and this is the path for me, G drive, and this is where I have saved all my folders. So this is my train, copy path, and we can just give here. So this is my train dataset path, and the target size of the images is 128 cross 128 and the batch size is 32 and the class mode is categorical since we have 6 classes. And then we save this in a folder called as train fed, and then we have another folder called as test fed where we have all the items same, just we have to change this particular one as test. So you can see this is my train data images folder and this is test images folder, and I have given target size as 128 cross 128, my batch size is 32 and my class mode is categorical. So this takes some time. So basically we have 14,049 images in our train data and 3,808 images in our test data. So now we will go ahead and define our CNN architecture. So we are not going to use any predefined model here. So let's start defining our layers. So we will use TensorFlow Keras. So here we will start with this format. So some people they use model equal to sequential and model dot add, that is one method. So that is where we need to import every convolution 2D, max pool 2D, dense layer, everything we need to import in advance. And this is the method where we don't have to import in advance, but it would be repetitive one, but we will try to copy and paste after first layer. So we start with TensorFlow.keras.layers.convolution 2D and I have 16 filters with 3 cross 3 kernel and my activation function is ReLU, and my input shape, since this is the first layer, is 128 cross 128 cross 3. This is my input shape, and then it has to be TensorFlow.keras.layers.maxpool 2D, and what would be my kernel size to pick the maximum value? It would be 2 cross 2. So this is my first layer. So we start with 16 filters here. So we can just extend this to 4 layer architecture. We will be building 4 layers basically. So here we will remove the input shape. We don't have to give this one at this moment since it's second layer, and we will extend this to 32 and our max pool will remain the same. This is my second layer, and then I will again paste the same. I would remove this and this would be my 64 and this will remain the same. So this would be my third layer of CNN, and again my fourth layer of CNN is 128 filters with 3 cross 3 kernel and activation function ReLU. So this is my fourth layer. So what changes did we do? We have given convolution 2D 16 filters with 3 cross 3 kernels, and we have given activation function ReLU and input shape 128 cross 128 cross 3, and then max pool 2D with 2 cross 2 kernel. And next we are extending to 4 layer architecture, and it started with 16 filters, then extended to 32 and then 64 and then 128 filters. So this is the 4 layered architecture. We are not going to extend this. Next would be our flatten layer, and then next would be our dense layer. So in dense also I am continuing with 128, and activation is basically ReLU, and then I'm using dropouts which is 0.5, and then I think I have done a mistake, there should be a comma error, and the third one would be my tensorflow.keras.layers.dense, and I have 6 classes, hence I'll mention 6, comma, activation is softmax since we have multi-class classification. So this is our model architecture. So let's run this one. This should be capital D. Sorry for the error. So it ran, and now we can see the summary, model dot summary, which will tell us how many parameters do we have in each layer. So we have 448 parameters here, 4640 parameters in the second one, and so on. We have total 688k parameters, trainable parameters. Now we will compile the model and we will use the optimizer Adam. So let's first import the same. Adam, and then we will compile the model, and the last function we use is categorical cross entropy since it's multi-class classification. And then we have the optimizer is Adam. Optimizer is basically Adam, and we have the metrics, the measurement, it would be accuracy. So we will be measuring in terms of accuracy for this particular model. So let's run this one. Functions. So first is from keras dot callbacks import early stopping, and then we have model checkpoint, and the third one is reduce LR on plateau, and the next library is import h5py. So basically our model weights will be saved in this particular format after training. Let's run this. Yeah, this has run. So we will have to now define after how many epochs, if the accuracy is not improving, do we have to stop running the epochs. So let's start with that. So early stopping, so it is early stopping I have mentioned. This has to monitor the validation loss. We can give validation loss or even accuracy, anything is fine. So this particular parameter will be monitored, and the patience is 6. That means after 6 epochs, if it is not improving, then we'll have to stop running. So restore best weights, true. That means while running the epochs, not necessarily the last epoch will give us the best results. So whatever epoch is giving us very good results, we will save the same. And then we will save model checkpoints. So basically model checkpoint, and our file path we'll have to give. So where do I have to save the model? So I will give a particular file path as content /drive/my drive. So this is where I am saving in the drive. I am not downloading to my local, and archive I will save as my model .hdf5. This is the kind of file we will be saving in. And what would it monitor? It would monitor validation loss and we will have to save best only. We will mention true, and then we have the third type, that is our reduce on plateau. So LR rate equal to reduce on plateau, and here as well we will monitor our validation loss, and the patience we are giving here as 3 epochs, and the factor it will multiply is 0, 1. So these are the functions we'll have to use for our callback. And now finally we will be training the model. So I'm giving history, it will save in the history. So my model dot fit generator. What is my train data? It is my train underscore fed. So if we go up once, this is my train data, this is my train underscore fed is my train data, and test underscore fed is my test data. So train underscore fed, and then I would say shuffle equal to true, where it will keep shuffling my images, and then my number of epochs is equal to 20. And then what is my validation data? It is test underscore fed, and I'll have to define the callbacks here. Callbacks are these 3 functions I need to write within the callbacks. So first is early stop, the second one is mod check, and the third one is LR rate. So these are the conditions I am giving, and then verbose equal to 2 to track the epochs. So this is my model. I'm training my model. So let's run this one. Point it takes a lot of time, hence I will pause it, and once we are done with 20 epochs or the callbacks conditions what we have given, whichever is earlier, so I'll again start the video once we are done with the epochs. Right, our epochs got over completed, so it stopped at 18th epoch. So now let's plot the results. So we would use a matplotlib for the same, and it is hist. We have saved in the variable hist. So hist dot history, and our we will plot for the loss, and the color for the same would be blue, and the label is train. So basically this is the train loss what we are plotting, and the second one would be for the test loss. We need to change here validation loss, and the color of the line would be orange. Usually these are the colors used for the plotting, though some other color also can be used. And now plot.grid should be true, and now I would give the title for the plot as train accuracy. So this would be basically loss, train and test loss with epochs. And then let me give the labels, X label and Y label. This would be training epochs in the x-axis, just to leave a one line space, and my font size should be 12. This should be X label, and then my Y label should be train and test loss, and the same font size should be 12. So this is also a place where we can write, we can remove space here, this was supposed to be here, and the font size for the title should be 16, and finally plot show. Yeah, so this is the train and test loss with the epochs. Now we can, this is as per the losses. Now we can plot the same as per the accuracy. We can just copy paste the entire one. Instead of the loss, we will replace with the accuracy. So now it would be with the accuracy. This would be accuracy, and this would be validation accuracy, and train and test accuracy with epochs. This should be accuracy. Yeah, so obviously the train accuracy is pretty higher and test accuracy is this. Now we can print the accuracy, how much percentage are we receiving. So it is model dot evaluate test fed steps is equal to length of test fed and verbose is equal to 2, and this one I am saving in something called as accuracy. Now print percentage dot 2f, so that we need 2 points after decimal, percentage accuracy, and that would be my first into 100, so that we are converting into percentage. So this takes some time. So this is basically 84.94% accuracy is what we have received in this particular model. So basically a couple of steps we have skipped down the line. So since this is from Kaggle, we have not used any visualization before defining the CNN layer, but in real life when we are tagging manually, it is very critical to see which are the images belonging to which class, or have they been tagged wrong. So these are the very important things to consider, but in this one, since it's from Kaggle, I have skipped them. So now our CNN model is ready, and we would be using Streamlit for the UI. So this is the file which I have already created, predict image class.py. So this is where we would be writing the Streamlit code, and this is where we would be running in this predict image class.ipython notebook. In this one, we will run the Streamlit created in this one. So let's get started. So this is where we would be writing the Streamlit code. So let's import all the libraries needed first. The first one is Streamlit, and the second one is images from PIL, and the third one is matplotlib, and then we would import TensorFlow, then TensorFlow Hub, and then NumPy. From TensorFlow dot keras import pre-processing, and then from TensorFlow dot keras dot models import load model, where we would be loading TensorFlow dot keras dot activations import softmax. This would be needed for the prediction, and the last one is import OS might be used, and the last one would be h5py. So this would be needed for the file of weights, and then we would start with the header. This would be giving the heading of our Streamlit app, image class predictor. Anything can be given here though. So I would basically have two functions. One is main function where we would upload the image, and the second function is where we would predict the class of the image. So the first one is define main. So I would ask the user to upload the image, hence it is st.file_uploader. So I would say choose the file, and I will also have to mention the type allowed for the files. Basically, since it's a CNN, we would allow JPG, PNG and JPEG. So these are the ones, and we would save this in file uploaded. And then we would have to write a loop. If file uploaded is not none, then I would process the image. So it would be image.open file uploaded, and I would save this in image variable, and then let me plot the figure, and this will be saved in a variable called as figure. And then let me show whatever I have created, plt.imshow, and this would be image, and the axis would be off, and predict class, which would be my second function name. I'm just writing it here so that it predicts result equal to predict class image, which will be written later, and then st.write result, st.pyplot figure. So we'll have to plot the figure. So this is our first function. So we have to make sure that the file uploaded is not none, else there will be difficulty in processing. Now first function is done. We'll have to go to the second function. Define predict class, which is for the image, and this predict class is here. So that is the connection between the two functions. And I would now have to load the model which we have created in the image classification CNN in the first one here. So the name what we have given is my model, hence we will have to load that particular model here, model weights. So tf.keras.models.load model, I would give raw, and or I can give directly since I know the path, content / drive / my drive / archive / my model dot hdf5. So basically we have given the path of this, and if I'm going back to the CNN notebook, you can see this in archive my model.hdf5. So the same thing I have given here. So this would be my model, and I have to save this in classifier model, and now I have to define the shape of the image, which is 128 cross 128 cross 3, and this should be same as the input shape of our model. So if I'm going back to the notebook, you can see I have given here the input shape as 128 cross 128 cross 3. It should be the same as this one, else it will throw an error. And then let me load the model weights with the help of hub.keras layer, and I would pass my classifier model, and the input shape is shape, and this one I would save in a variable called as a model. And now I have to resize the image, which is 128 cross 128, and I have to save this in a test image. Now we have to preprocessing dot image to array, and this would be the test image, and again this would be saved in test image. I am not doing any changes in the variable name to maintain the consistency, and then I have to divide by 255, and this would be again test image. I'm just copying, and finally I have to expand np.expand dimensions. Sorry, there is an error. Expand dimensions, test image, and access is 0. Now I have to define the class names. So we remember we were having 6 classes when we started in the beginning. So the first one is buildings, then it is forest, then it is forest, then it is glacier, and mountain, and sea, and street. So these are the 6 class names we have to give here, and finally we would be writing a code for prediction. So we would say model.predict. So here we have written model, so model.predict, and it would take the test image which we have processed, and it takes predictions, it saves in the variable predictions, and finally I would be using softmax to do the predictions. Softmax predictions 0, and I have to save in the scores. So it would use a softmax to predict, and now I would say scores equal to scores dot numpy, and now I would say class names np.argmax of scores. So here we are using softmax to give us the probabilities, and we are saying here argmax np.argmax of scores. So whichever probability value is highest, it would return that particular class name or the corresponding class name, and we are saving it in something called as image class. And the result we would say is the image entered or the image uploaded is the whatever predicted one. So we would say format, and that is particularly image class, so we'll have to write here as image class, return result, and finally if name equal to main, I would say main. So this concludes our predict image class 5. Here we have got two functions here, but sometimes it can be clubbed to one. There is no, absolutely there is no necessity that we have to create one function to just take the image and another function to predict. Not necessary. This is the time I have done like that. Sometimes we even merge and we can just write one function. That is absolutely fine. So finally we'll have to go here and call this particular predict image class.py. We have to call in this particular IPython notebook. Usually in local we do this with the help of shell, but since it's in collab and we need GPU as these are images, and hence we will take help of IPython notebook. Alright, so we have come to the notebook file predict image class, and I have got the drive here. Now we need to get this ng-rock for our Streamlit app. For local it is absolutely not required, but for collab it is required. Hence we have got one line where we would get this particular ng-rock. So this is the link. So this is the zip file where we have to get this. Let's close this one and we'll have to run this. This may take some time. If it is taking longer time, I would just pause, else we would continue. Yeah, it ran immediately. Great. And now we'll have to unzip the above file. So it is ng-rock stable Linux AMD 64 zip. So we'll have to unzip this. Great. So this also ran. Now we would have to activate the same. Hence we would say get IPython dot system. Let's go to raw. ng-rock http 8501 ampersand. So basically we will have to give the particular port number 8501. we will have to mention it specifically here. Now we can run the same. And next we would go for curl command, curl -s http /localhost, and the port would be 4040 API /tunnels, and then Python 3-c and a backslash. This is the command, and next we would just write a line of code saying import sys and JSON and print execute the next line, and then go to the ng-rock URL and plus JSON dot load. Make sure you don't have any spaces here after the double quotes. JSON dot load, and this would be sys stdin, and then we will define the tunnels saying tunnels and then 0 and then public URL and then close the bracket, single quote. So this is the command we need to enter. So after running, you have got this ng-rock code, and now finally we need to install. If we have not installed Streamlit in advance, we need to pip install Streamlit, and now this would be Streamlit run. So this would be on shell. So Streamlit run, and I have to give the file of the predict image, the py file which we have created. So we have to give the path of this one, content drive, my drive, and then archive, and then I have saved this as predict image class.py. This should be the final command we need to run, and after running we need to go to this ngdoc IO. And after running this command, we have now got two links in network URL and external URL, which we are not going to use. We have to go for this ngdoc.io. This would be our final app. So this is the small app, and we have to upload files. Let's see. So these are the images available on that pred folder given by Kaggle. So let's see, we'll randomly upload some 2-3 images and check how our CNN model is performing on the images. So this is basically a forest, hence slightly not clear, but this is the forest. You can see green trees. So this is being predicted properly. And then let's try one more file. Probably this is the one. Let's try and see how it is working. So this is basically a mountain. Open. Yes, this is also predicted properly. This is a mountain. So let's see one more image how it's working. Basically, let's try this. This is basically building. See, this is where it is not working. So basically it is thinking it is a mountain, but we can clearly see these are the buildings here. So we have tried on 3 images, we got 2 right and 1 wrong. So basically our model had given us around 85% accuracy, and this is decent. This is definitely in real time, if production code, then it should be 95% plus accuracy for sure. But this is decent one. So fine, then we will be back with another video. See you soon.